Hi students, today we are going to derive an expression for the work done by a constant force. We have already studied in the class when is work said to be done. Work is said to be done only when a force acts on a body and the force produces a displacement along the direction of the force. Also we have studied work done by a force is a dot product of the force vector and the displacement vector. Now here let us consider this is a block of wood. So a block of wood is placed on a flat plane surface and a string is tied to it along which a force F is acting. Just like you imagine you are pulling an object with a rope which is inclined at an angle theta to the horizontal. Okay, in this case the object is not going to move along the direction of the force. It is going to move along the direction AB, that is along the direction of the displacement R. So the angle between the force vector and the displacement vector is what? Theta. So actually I am moving the object from the initial point A to the final point B from an initial displacement Ri to a final displacement Rf. So in between this initial and final point, I will divide the entire distance AB into infinitesimally small intervals, that is infinitesimal displacements dr, like this. So what is the work done in moving this body by applying a force between 2 points separated by an infinitesimal displacement dr? So for that, the small work done, first we will find out an expression for the small work done for a displacement dr. So this is denoted as dw and this is equal to force vector F dot displacement vector dr. So this is equal to F into dr into cos of the angle between the two vectors. This is the vector definition of work done. Now, this work is actually done between the initial point A and the final point B. Therefore, total work done. So, what is the total work done? In this case, the total work done is given by capital W and that is equal to what? Integral of dw. This is equal to integral of F dot dr, or this is equal to integral of, so this is also equal to integral of F cos theta into R. So I will take F cos theta into dr, okay, dr. Now, what is the type of force we are applying here? It is the force, constant force F, is it not? Also, this angle theta is also a constant. It is not going to change. So, F cos theta must be a constant. Therefore, this work done also is equal to this constant F cos theta taken out of the integral into integral of dr. Now, dr means what? It is a variable which gives the information about the changes taking place in the displacement from the initial point to the final point. So the lower limit of the displacement must be at point A, that is R initial, and the upper limit of the integral is the final point R final. Okay, so this is the expression for the total work done by the constant force in displacing the body from a point A with R initial to a point B with R final. Understand? So W is equal to F cos theta into dr. So this is now equal to F cos theta into integral of dr is R. So from initial Ri to final Rf. Now, while substituting the value of this integral, first upper limit we have to substitute minus of lower limit. Therefore, W is now equal to F cos theta into the upper limit Rf minus the lower limit R I. So this is the final expression for the total work done by a constant force. Now the same can also be represented by a graph. So the y-axis is f cos theta, which is a constant, and this is the displacement r. Now the displacement changes from initial value Ri to a final value here Rf. So from the initial to the final point, the force F cos theta remains always constant. So at all points, this will be a constant. So if you join all the points, what is the nature of the graph is a straight line which is parallel to the x-axis. So project the initial point and the final point on the x-axis, you will get a closed curve like a square or a rectangle, and find the area. So the area, you see here, what is the height of this rectangle? It must be equal to what? F cos theta. And what must be this length? This length must be equal to r final minus r initial. So this is r final minus r initial. By formula, what is the area of a rectangle? Length into breadth, is it not? Therefore, here the area of this closed curve, or the area of the graph, we can say area under the graph. So this is equal to length into breadth. So this is equal to f cos theta into breadth is r final minus r initial. So this is equal to what? The work done by the constant force. Work done by the constant force. So this is a very important information. For solving problems, we have to use this expression W is equal to F cos theta into R final minus R initial. Suppose R initial is 0, means that directly it is F into R into cos theta. That is nothing but F dot R. Is it not? I hope you must have understood this well. Fine.